All right. Um, so if you look at your, actually, hold on. If you look at your worksheet, here we are. We're going to be taking absolute value functions and writing them as piecewise functions. So at this point, since we're getting started, I shouldn't see any cell phones. I shouldn't see anybody typing on their cell phones. I'll take them if I see them. Earbuds should be gone. If I see earbuds, I'm taking those too. No headphones, no earbuds, no cell phones. All right, and you should be signed into Desmos. Okay, so the first function we're going to graph, we're going to start with f of x equals a piecewise function. When you get into math classes, starting in math 3 and then beyond, they start working with piecewise function and they start to phase out absolute value functions. It doesn't mean that you never see them. It just means that they are hard to work with because of those vertical lines. And so whenever we see one, we would convert it into a piecewise function. So that's what I'm going to teach you guys how to do today. So let's go ahead and let's go to Desmos and we're going to graph it. So y equals absolute value of x. We're going to get that plugged in. We're going to get some points off of the graph. So everyone remember how we get those points off the graph from Desmos? What? Yep. So I'm graphing all the points that I can see on here. I'm graphing 0, 0 and 1, 1 and negative 1, 1 and 2, 2 and negative 2, 2. And I'm going to use colors today like I often do. And if it's helpful for you to use colors and you don't have any at your desk, you are welcome to grab some. So a marker would work for today. You can also use a colored pencil or a colored pen. So there's some more points on the graph if you want to graph some more. And I'll show you guys what I've got. There's mine. All right. So if I was to take this graph and I was to cover up just the right side of it, I make it so it's not a V-shaped graph anymore. This looks like a straight line graph. We usually write straight line graphs using what equation? Y equals mx plus b. So I'm actually going to write my equation that way. I'm going to use f of x instead of y because this worksheet used f of x instead of y. And then I'm going to do mx plus b. So can you guys tell what this slope is over here? What's the slope? It goes 1 over 1. Is that a positive slope or a negative slope? Negative. So it goes down 1, right 1, down 1, right 1, down 1, right 1. Okay. So I'm going to do this part in one of my colors. Just this part right here. It goes down 1 over 1, down 1 over 1, down 1 over 1. So this has a slope of negative 1 over 1. And then can you guys tell what the y-intercept is? 0. So negative 1 over 1x plus 0. Okay. And then if I cover up the other side over here, what about this part of the V? It's a positive slope. And so what does it do over here? Okay, so it goes up 1 over 1, up 1 over 1, up 1 over 1. So the slope is positive 1 over 1, x. What's the y-intercept over here? Where does it cross the y-axis? 0. Okay. Okay, now anytime we do this, we have two pieces to this function. We have the left side and the right side. Anytime we do that, we do this. It's a squiggly bracket. And yes, you have to draw the squiggly bracket. So we're going to say y equals both of these pieces. And what we have to do is we have to figure out when we use the left side and when we use the right side. So what is the x value that we used to split this graph in half? We used an x value of 0. This right here is an x value of 0. It split the graph in half, okay? So I'm going to say if x is to the left of 0. We used the pink side if x was to the left of 0. We used this, it's a purple marker, but it kind of looks blue. We used the purple side if x was to the right of 0. Wait until we've done a couple examples. Okay, so we use pink if we were to the left of 0, purple if we were to the right of 0. And then we didn't skip 0, like 0 is on the graph. It's not a hole, it's not missing. The graph actually goes there. So for one of these, I'm going to say that I should have x equaling 0. There should be an equal. And because if you were to look here and say, well, is 0 included on the pink or the purple? It's like, well, technically neither, because 0 is just like smack dab in the middle. So I'm just going to include it on the left side this time, but maybe next time I'll include the middle on the right side. It doesn't really matter. Okay. So I'm going to show you guys how to do this on Desmos because Desmos can do this as well. So let's go back to Desmos. I'm going to get rid of my table. I'm going to leave that there. Now I'm going to click on this because I'm going to turn this off. I don't want to see this anymore. And now I'm going to tell Desmos, okay, I want you to graph the left side for me and I want you to graph the right side for me. So I'm going to say, Desmos, I want you to graph -1/1 x plus 0, but I only want you to do it for x values that are to the left of 0, okay? And this is how you tell Desmos to only do it for x values that are to the left of 0. You do a squiggly bracket, which is next to the P key. Does everyone see that squiggly bracket next to the P key? So I'm going to hit Shift and then this key that's next to P on my keyboard. Everyone see that? And then I'm going to do x less than 0. See how it just gave you the left side? Okay. Now I'm going to go down to the next line. I'm going to do y equals 1/1 x plus 0. And I'm going to tell the graph, but I only want this side of the v if x is to the right of 0. So again, I'm going to do Shift. And this time I'm not doing the key that's right next to the P. I'm doing the one that's next to that. Right, Caitlin? So I'm gonna, nope, I'm gonna do the same one, the one that's right next to the P, just kidding. X is greater than 0, so to the right of 0, and then I can see the left side and the right side of the V. Now, if I go back and turn the red graph back on, you can see that, oh, I'd have to turn these off. Hold on, turn it off. You can see that the red graph is in exactly the same spot that those graphs were in. So the blue and the black are in exactly the same spot that the red graph is in. You guys see that? Okay. So it's just another way of graphing an absolute value. And again, the reason we're learning this is because in future math classes, they don't like to use absolute value. They want to use pieces that are easier to work with instead. And a straight line is easier to work with than a V-shaped graph. And so we translate them into the straight line graphs instead. Okay, let's try this again with the next one. So the next one says, okay, we're going to do -2 times the absolute value of x. That's what we're going to graph first. And then we're going to find the two straight line pieces we could use instead. So I'm going to go to Desmos. Going to get rid of these. Going to type y equals -2 absolute value of x. And I'm going to get my table pulled up so I can get some points. So I'm going to graph these. So 0, 0, -1, -2, -2, -4, 1, -2, 2, -4. Getting those points graphed. Wait until we do a couple examples. All right. So if you guys look at this, can you tell what the slope is on the left side of the graph? What's the slope on the left side of the graph? Now, does the slant go up or go down? Wait, if you were walking up this slant goes up, right? This is a positive slant. So we're going to go up. How many? 2 over 1. Up 2 over 1. Okay. Up 2 over 1, up 2 over 1. Okay. And then what's the y-intercept? 0. Okay. Let's do the other side. Is the other side an uphill slant or a downhill slant? Downhill slant. So the other one is going to have a negative slope. What's the negative slope for this one? So it goes down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Okay, and what's the y-intercept for this one? 0. Okay. And then what is the x value that cuts this in half? What x value do we have right here that cuts this picture in half? What's this x value? 0. Yeah, right here. This is an x value of 0. Here's an x value of 1, x value of 2, x value of 3, x value of 4. This is an x value of 0 right here. The x value of 0 cuts this picture in half. So I'm going to say if you're looking to the left of 0, if you're looking to the right of 0. So if you're on the left side, if you're on the right side. And we don't skip 0. It's right in the middle, but we don't skip it. There's no gap in the graph. So last time I included 0 on the left side. This time I'm including 0 on the right side. Does it matter which side I include it? No. All that matters is I make sure that I'm not skipping it because the graph does not skip it. Okay? 0 is not a gap. It's there. So it doesn't matter if you include it on the left side or the right side. You just have to include it on one of them. Okay? Now, would most math people put 1 over 1? Would they even put a 1 at all? Would they put a 0 on the end? Probably not. How do you think most math people would write these answers? Probably just x, right? Negative x, yeah. Okay, so they would say this answer, if they were to write it in the final format, they would say negative x. Because technically when you have 1x, you don't even have to put the 1. So they would just say negative x. Can you put the 1 if you want to? Yeah. Can you make it a fraction if you want to? So if you like it like this, you can leave it like that, but most mathematicians would not. They would just say negative x. Can you put a 0 on the end? Yes. Do you have to? No. Most mathematicians you see would not put the 0 there. What should we write for the other one? Just positive x. Okay. Now we should put this part. If you're looking on the left side of 0, if you're looking on the right side of 0. And then I got my little equal to. So this is what your answer would look like. All right, how would this one look? Would they write the 2 over 1? Would they write that like a fraction? 2 over 1? They would probably just put 2x. 2x, would they put the plus 0? Probably not. 2x if x is less than 0, if we're looking to the left of 0. What should I put for the other one? Negative 2x if x is to the right of 0. And then I'm going to put my equal to sign right there. Okay. All right, we're going to get into ones that are a little bit different because we're going to start to move them around. You can see these transformations are moving things around. Can you guys remind me what these transformations are? We got a 3 in the front. What's a 3 in the front? Multiplication. And what is it? Stretch. It's a vertical stretch of 3. Right 5. And up 1. Okay, so vertical stretch of 3, right 5, up 1. Let's go ahead and graph that on Desmos. So I'm going to get rid of what I had typed already. 3 x minus 5 plus 1. Okay. And I'm going to go ahead and get my table in there. My table did not give me any points. How do I get my table to give me points? Press enter where? Put my cursor after the 2. So I'm all the way over here. I'm past the 2. Put my cursor after the 2 and do what? Press enter a few times. Oh, there we go. A point showed up. Okay, so we got some points now. Okay. So we've got the vertex at 5, 1, 6, 4, 4, 4, 3, 7. Oh, we can graph 3, 7. 3, 7, and 7, 7. We can graph all those. So over 5 up 1, over 4 up 4, over 6 up 4, over 3 up 7, over 7 up 7. So there's our graph. So if you can't see the points, Eddie, here's the points on Desmos. So we need to write down what's happening on the left side. What do you guys see on the left side? Let me maybe Zoom. Oh, there we go. Can you guys see what our slope is on the left side? I can't see it on my paper very well, but I'm going to be able to see it on Desmos. So I changed my zoom. You guys might have to zoom out the way that I zoomed out so that I can see the boxes, how many it's going over and up, so I can do my equation easily. So I can see my slope now. And if I go back to my paper, I can see the slope pretty easily on my paper. So what do you guys see on the left side? Are you going uphill or downhill? Okay, so this is downhill. So when I write my equation, I'm going to have a negative for downhill. So what is my slope? Okay, so I'm going down 3 over 1. Down 3 over 1. Okay. Now, I can't see the y-intercept on my paper, so I'm going to go back to Desmos, and I'm going to use Desmos to help me find the y-intercept. Okay, so the y-intercept for this is 16. Okay. So negative 3 over 1x plus 16. Okay. And then let's go ahead and do the other side. Can you guys tell what the slope is for this one? So 3 over 1x plus, and then I could follow that pattern down here, but it looks like it'd be a little bit too low. So do we think it's 16 again? Probably not 16. Let's go ahead and use Desmos to help us figure it out. So I'm going to go back to Desmos and just see. Ooh, this one's hard because I have to kind of imagine where it would cross. I can't see where it would cross. So let's go ahead and let's type in, it's going to go 3 here. We're just going to kind of follow where we think it would go. Down 3 over 1. Everyone agree with that? Down 3 over 1. We still good? Down 3 over 1. Down 3 over 1. And then, oops, we got one more to go. Down 3 over 1. Do we agree with this? So we think it's going to be negative 14. Let me type in an equation over top and see if it works. So we think it's going to be 3x minus 14. Okay. Does that make sense? Do you guys see how it's right on top of that side of the V? Okay. So 3x minus 14. Now, do you see how this one got a little bit more difficult? This problem, not as easy as the other problems. Like the other problems were pretty easy. These ones got a little more difficult. So we want to see if there's a shortcut for doing this one. Okay. Negative 14. No, you guys were right. Negative 14. Minus 14. Thank you for that correction. Okay. Minus 14. The positive was a typo. Okay. Minus 14. Now, the next thing we need to do is we need to figure out what number cuts the V in half. So what is the X value? We say use the pink half if you're to the left of this X value. Use the purple half if you're to the right of this value, and the value is 5. 5 is the X value that cuts this graph in half. So we're going to say if X is to the left of 5, if X is to the right of 5. Okay. Are you guys ready to see how you would do it if you didn't have a graph to look at? I scribbled this out and put a minus. And then one of these has to be an equal to, it doesn't matter which one. I usually alternate and just go back and forth. Okay, so here's how you do the problem if you don't want to have to graph it, or if the graph is not going to be very easy. For the left side, for the right side, I'm going to show you guys how to show your work, okay? For the left side, you do the negative version of whatever the original problem is. So the original problem had a positive 3. So I'm going to do the negative version of positive 3. What's the negative version of positive 3? -3. So I'm going to say -3 times, and notice I changed the vertical lines into parentheses. On the right side, you do the positive version of whatever the problem was, or you do the same version that they gave you in the original problem. Okay, left side, you do the negative version, right side, you do the regular version. Okay, and then what you do is you just get rid of the parentheses. Okay, so left side is this way, right side is this way. Okay, left side, the right side. Okay, so if I'm getting rid of my parentheses, I'm going to do -3 times x, -3 times -5. What is -3 times x? -3x, okay. What is -3 times -5? Is it -15 or +15? +15, okay. And then we have a +1 on the end. What is 15 plus 1? 16. So we have -3x plus 16. Does that match what we got for the left side? Yes, okay. Now for the right side, we take the version that the original problem gave us, which happened to be a +3. We distribute the 3. So we get 3 times x is 3x. What is 3 times -5? -15. Plus 1 on the end. Okay. What is -15 plus 1? -14, right? Because we have a negative and a positive. So we have 3x minus 14. Does that match the answer that we got? Yes. Okay. So what we're going to do on the next one is we're going to use this method and see if it supports what our answer is in the picture, if it makes sense with the picture. Okay. So let's flip the page over. Let's try the next problem. Yes. I don't know what my code is. Sorry. I'm not signed into eHallPass, so you're just gonna like sneak. Okay. All right. Let's go ahead and try this one. So we're going to graph this on Desmos. So let's get rid of everything that we have up here. Y equals -2, x plus 1, minus 3. So there's the graph. I'm going to go ahead and pull up the table. There's the points. So -1, -3, -2, -5, 0, -5, 1, -7. And if I want to do one more, Caitlin, you still with us? Let me see your notes. You have 3, -7. Hold up your notes. I want to see them. All right. So here's my points. All right. On the left side, we do the negative version of the number that's in the front. We do the negative version of the number that's in the front. So what number do you see in the front? -2. So I'm going to put the negative version of -2. the negative version of -2, and then x plus 1 minus 3. For the right side, I do the regular version. The regular version. So -2, x plus 1 minus 3. Negative version for the left side, regular version for the right side. Eddie, I need you to take that earbud out. Negative version. Regular version. We have two negatives because we did the negative version of -2. Negative, negative. What happens when you have a negative, negative? Positive. Negative, negative makes a positive. So negative times negative makes a positive 2. Okay. Yep, there's a -3 on the end. Okay, so now that I've fixed my minus minus, what do I do with this 2? I multiply it. 2 times x, 2 times 1. What is 2 times x? Okay, what's 2 times 1? 2. What's 2 minus 3? So I have 2x minus 1. Okay, so the left side of the graph is a slope of 2 and a y-intercept of -1. That's the left side of the graph. Let's figure out the right side of the graph. -2 times x. -2x. -2 times 1. -2 times 1. -2. Minus 3. What's -2 and -3? -5. -2x minus 5. So a slope of -2 and a y-intercept of -5 for the right side of the graph. Okay, so we're going to say f of x equals, and we're going to write the left side of the graph, the right side of the graph. The left side of the graph, the right side of the graph. If you guys look at the left side of the graph, do you guys agree that it has a slope of 2? Up 2 over 1, up 2 over 1? Does it look like if you were to continue this line that it would have a y-intercept of -1? Does that look like that would have a y-intercept of -1? Yeah, okay, so that one fits. Does the right side of the graph have a slope of -2? Does the right side of the graph have a slope of -2? Does the right side of the graph have a y-intercept of -5? Okay. Now, can you guys tell the number that splits the graph in half from left and right? What is the x value? What is the x value that splits the graph in half left and right? -1. Okay, -1 is the x value that splits the graph in half left and right. Okay, so we're going to say 2x minus 1 if x is on the left of -1, 2x minus 1 if x is on the right of -1. Okay, let's try the next one. Left side, right side. Left side, right side. Okay. Tell me what to do. Which side do you put the negative on? The left side. So the left side, I do the negative version. The right side, what version do I do? The regular version, okay. All right, and now what should I do? distribute -2 times x, -2x, -2 times -4 is +8 plus 3. What's 8 and 3? 11. Right, Chris? 8 and 3 is 11. Right, Chris? 8 and 3 is 11. Right? I had to yell into your dream to make sure you heard me. Okay. And then over here, what do we do? Distribute 2x, and then what? 8. 2x minus 8 plus 3. And then what do we have? 2x minus 5. They tricked you. They tricked you. How come it's not 11? Negative and positive. Okay. So now let's start writing our equation. We got the left side. We got the right side. We got the left side. We got the right side. Okay, we're going to figure out how to get the next piece without a picture. Okay? So here's what I want you to do. We're going to go back to the front of our page. And example 1 and 2 aren't going to help us find it very well, but example 3 and 4 are really going to be helpful. So let's go back to the front of our page. I'm going to grab another color marker. Here's what I want you to do off to the side. Tell me what the vertex is for number 1. 0, 0. Okay. Okay, so the vertex is 0, 0, and we split it in half. We said if x is to the left of 0, if x is to the right of 0. Okay. We're gonna find it in a second. We're gonna get there. Example 2, what's the vertex? 0, 0, 0. Okay. And when we looked at splitting the graph in half, we said if x is to the left of 0, if x is to the right of 0. What's the vertex for number 3? 5, 1. And here we said if you look to the left of 5, if you look to the right of 5. Okay, let's flip. What's the vertex for number 4? -1, comma, -3. And we said if you look to the left of -1, if you look to the right of -1. Our vertex is going to be 4, 3. So what number is going to split this in half? 4. Okay, so let's go back. We're going to grab our marker. We're going to start at number 3 because this is where it's obvious. You use the x coordinate of the vertex, and that helps you choose which number splits your v in half. The x coordinate of the vertex helps you choose what number to split your v in half. Which makes sense, right? Your vertex is where the v splits in half. And the x coordinate is going to split it from left to right. So it makes sense that it would do that. So here the x coordinate of the vertex was 5. We said if you look to the left of 5, if you look to the right of 5. Here, the x coordinate of the vertex was -1. So -1 is where we split left and right. So here, the x coordinate of the vertex is 4. So we're going to be splitting our picture. We're going to say if x is to the left of if x is to the left of 4, if x is to the right of 4. So we use the x coordinate for both of them. Okay. All right, now one of these has to have an equal to, and I missed this on the last one. One of these has to have an equal to, it does not matter which one. You can alternate, or you could say I just use the top one each time. It doesn't matter what you do. So that one we did without even drawing the picture. Okay, let's try the next one. We're going to do left side, and we're going to do right side. All right, left side, what do I do? The negative version. Okay, so now what should I write? Okay, x plus 8 minus 3. Yep, minus minus makes it positive. All right, and then what do I do for the right side? Keep it the same, use the regular version. X plus 8 minus 3, okay. Distribute the 1/2. So I got 1/2 x and then 1/2 of 8. 1/2 x plus, what is 1/2 of 8? 4. Okay. So 1/2 x and then positive 4 minus 3, 1. 1/2 x plus 1. Okay. Over here, negative 1/2 times 8. So negative 1/2 x. We said 1/2 of 8 is 4. What is negative 1/2 times 8? Negative 4. And then we have negative 4 and negative 3. Negative 1/2 x minus 7. Okay, so we got our left side, we got our right side. F of x. We got our left side. We got our right side. So if x left side, if x right side, okay? And then for our vertex is negative 8, negative 3. So I'm just going to take this and go zoop. Negative 8, negative 8. Goes right in there. Okay. How do you guys feel about these? They're kind of weird. Now, do you have to do them like this? Or could you use Desmos to kind of help you with drawing the graphs? Yeah, so if you're struggling, you could definitely use Desmos and just kind of graph the lines and see. We're able to do it that way too. It'll take a little bit more time, but you can like use your brain to kind of think it through. So I'm going to hand out the assignment. There are 10 problems. There is a graph there in case you want to graph it. You do not have to graph it. You do not have to graph it, okay? If you want to just do this, that's fine.
We don't have to graph?
You don't have to graph it. You can just do this work, okay? However, I need to see work for each problem, okay? Everyone hear that? I need to see work for each problem. All right, let me pause this.